Function handles are useful when doing things like plotting symbolic expressions over an unknown range. We're going to use that @x to describe this when we create a figure. So for instance here, we've set up a new figure. We've run fplot with @(x) cosine of x. And it's chosen to plot this from -5 to 5, and it's automatically chosen that range and the domain. I could do the same thing by saying @cos in this case. And MATLAB returns to me a similar result. Because we can do this with single line statements, we can define a function in a single line statement. Besides fplot, which plots a line plot, there are other things available like fcontour. So in this case, we see a contour which has high points in yellow, low points in blue. Parametric plotting allows you to describe an x as a function of t and a y as a function of t. So x and y both vary, and you're able to draw things like circles or curves very easily as a function of a single value t. In this case, what we see is that from above we can see certain shapes, from the side we can see certain shapes, but all in all, we're getting this 3D semi-helical value in this case, because it's varying over both x and y as functions of t. There's also a surface plot. So you see what happens here is that we've created an x as a linspace from -5 to 5 and y as a linspace from -5 to 5. We've used mesh grid. You'll see that x and y are represented as 100 by 100 arrays of doubles. What mesh grid does is it produces an x that contains the x values of each point all the way across, and a grid of y's which contain the y value for each value all the way down the row. So when you calculate z, in this case sine x times cosine y, it's pulling the x and y at each coordinate point from that grid. And we're able to use surf with that and get a very nice plot. And again, all of these things are things that we can go in with edit plot. We can affect the lines and the way that the color map and the shapes and everything are behaving in this instance.